Hi again, students. It is still me, Miss Leia, and in this video, we're still going to talk about freely falling bodies, but this time, we're down to the second to the last learning target, which is to execute the problem-solving steps for freely falling bodies that are thrown downward. So, in short, we'll be talking about case 2, free fall, because case 2 refers to objects that are thrown downward. And just a little recall, remember that for objects that are thrown vertically downward, the magnitude of initial velocity has to be greater than zero. Of course, you cannot propel something downward unless you impart a certain amount of momentum or velocity on it. So the magnitude of the initial velocity has to be greater than zero. And for the sign, it should be negative because a downward velocity is associated with a negative direction. That's it. I don't want to get any copyright issues for this one. So, if you're familiar with the show Game of Thrones that has actually already ended, there is this one scene there that immediately came to my mind when I thought of making a case two free fall problem out of a certain scene in a show or a movie. And this is how it looks like. So those are the Lannister soldiers on top of the castle wall, and they're actually throwing down those rocks on the Unsullied soldiers of Daenerys Targaryen. Yeah, and they're actually throwing it. If you look closely, you can see that they're imparting so much momentum on those rocks. They really throw it downward. So it's actually case two pre-fall. They don't simply release it. It's not case one. Case one, that's case two because you can see them if you watch closely, repeat this one. And the uploaders, Christina, are okay. I luckily I found this after watching it before. So it's an example of a case to recall. And the question I made out of it is that suppose a Lannister soldier can throw a rock at a velocity of 10 meters per second downward. From what height should the rock be released for it to hit an Unsullied's head at a speed of 15 meters per second? Okay, so those are the Lannister soldiers, just so you can more easily understand the question. And the Unsullied soldiers are those who are trying to make their way up to the castle wall. Now let's try to work it out. So same steps as the usual physics problems in free fall. We're just gonna start with identifying the variables. So let's say, for example, suppose a Lannister soldier can throw a rock at a velocity of 10 meters per second downward. What exactly is 10 meters per second downward? If you look at the units meters per second, it's obviously velocity. And it also says here directly, that's velocity, right? But is that initial or final? Obviously, that's initial velocity, right? So it's like, this would be the, wait, okay. So you can think of it as if this is the castle wall, and then those men are actually here, and then they're throwing those rocks downward. Okay, not quite accurate because they're supposed to give it a downward push, but yeah, that's it. And then their enemies were here. They want those rocks to hit those unsullied soldiers as hard as possible. Of course, at least we assume, right? And it says here that a Lannister soldier here can throw a rock at a velocity of 10 meters per second downward. So is that initial or final? Obviously, that's initial velocity, right? So the initial velocity in this case is actually 10 meters per second. Is that all? There's something lacking there. We have to add a negative sign because it's a downward velocity, right? So they're being thrown downward towards those enemies. Okay. Now, what else do we know in the problem? From what height should the rock be released for it to hit an Unsullied's head at a speed of 15 meters per second? So those Lannister soldiers, it seems like what they want these Unsullied to experience is a speed of 15 meters per second. So that's faster and that's more kinetic energy, and that's going to be more harmful for these poor creatures, right? So the target velocity or speed at this point should be 15 meters per second. In kinematics, we're actually dealing with v dot, right? If you can still remember this, okay? So, and take note that these are actually velocities. So even though the problem mentions about speed as 15 meters per second, we would like to add a negative sign to that to make it velocity because velocity has the direction, right? It's how fast something is going and in what direction. So it has to be 15 meters per second. That's the final velocity that these Lannister soldiers want the rocks to have. Okay. And then obviously there's always this automatic given that's not directly stated in the problem, but because we assume that the rocks are in free fall, the acceleration would be negative 9.8 meters per second squared. Now, let's try to figure out what we have at the moment. Okay, so we have v sub I, v sub f, and acceleration that are all given, and therefore, what's the RTF? From what height should a rock be released? Okay, so obviously, we're actually solving for displacement. And in this case, if displacement is the RTF, the missing variable would be the missing variable would be time, right? Okay, once again, the given variables in the problem are v sub I, v sub f, and acceleration. And then the required to find is displacement. The term they use is actually height, but height would be equivalent to displacement in this particular problem, okay? So therefore, the missing variable in the problem is time. Time is the variable that's not a given and it's not the RTF either. Okay, but what does it imply? If time is the missing variable, once again, we have to pick the equation that does not contain time, and that's equation 4. So let's write that down. So our equation would be vf squared equals vi squared plus 2ab. Once again, we're picking this equation because it does not contain the missing variable in the problem, which is time. Now, what's the next step? Okay, we're solving for displacement. That's what you have to keep track of. Therefore, we have to isolate that. Now, let's go to the next frame of this particular so that we can have more space to write on. So that's vf squared equals v sub I squared plus 2ad. There's nothing zero among those given, so there's nothing that we can easily cancel at the moment. So the equation would be as it is, except that we have to isolate d. Now, how do we isolate d since it's the RTF? The basic thing that we have to do is to get rid of all those variables that are surrounding d, that are with d on the same side of the equation. And my personal technique is that if you have that plus sign, for example, whatever is not together with d in that particular expression, it's better to get rid of them first. Let's say, for example, there's a plus sign and it separates vi squared from the rest of this expression. We can get rid of v sub I squared first, and we can transpose it on the left side of the equation. So it will become vf squared equals, vf squared minus vi squared equals 2ad. So once again, whenever we transpose something on the other side of the equation, the sign should actually change. So from positive, it becomes negative. Another thing I'd like to emphasize, if there's a plus sign that separates that expression from the other expressions, you have to get rid of this by transposing. Okay, you can do divided by vi squared, for example. That would be wrong. Okay, if it's separated by a plus sign, you can transpose it on the other side so that you have less expressions now on the right side. Okay, now we're gradually isolating d. The next step would be divide both sides by 2a. Okay, so that's 2a. And with that, we can cancel this now. Okay, and what we have at the moment is vf squared minus vi squared over 2a equals d. Now, I'd like to write d on the left side. So I'm going to flip this horizontally, the equation. So it will become d equals vf squared minus vi squared over 2a. There we go. Now, the next thing we have to do is to plug in because we have isolated the required to find already. Okay, so that would be d equals final velocity is negative 15 meters per second. Okay, and then raised to 2 minus, wait, this has to be squared, minus initial velocity is 10 meters per second, negative raised to 2. Okay? And then negative 15 raised to 2, that would be positive 225 meters per second minus negative 10 raised to 2 is positive 100 meters per second. Okay? Over, okay, 2a. Sorry, I forgot 2a here. There's 2a there. Okay? And then that a is negative 9.8 meters per second squared. Okay. Now let's do the math. Well, we can use a calculator for an easier life. So that's gonna be 125 divided by 19.6, negative 19.6. Okay, you're gonna have 6.38 meters with a negative sign, right? It will come out as negative because um in the numerator you have positive because 225 minus 100 is positive 125, and then this is negative 9.6, 19.6 rather. Negative 9.8 times 2, negative 19.6. So you're gonna have, okay, positive divided by negative. So this will be the final answer. Okay, and now let's go back. Let's check. Okay, that's right. So 6.38 meters. As you can see in the slide, it says positive 6.38 meters. It's simply because it says height in the question. And when you say height, that's actually a scalar quantity. Height is not something that's associated with direction. It's just how tall something is. You don't say my height is 5'6" upward or downward. Okay? So height is a scalar quantity. Although in the problem, it appears to be negative because the kinematic variables make us having to solve for displacement. And it happens that displacement is actually a vector quantity. So it will give us a sign, which is actually consistent with the scenario, right? Because once again, if this is the object's origin or original position, that displacement is actually below the object's point of release. So it will really come out to be negative if you apply kinematics, okay? But when you report the answer and it says from what height, the most appropriate way of answering it is by reporting it as a positive number because height is a scalar quantity. It doesn't have any direction associated with it. So it's not supposed to be negative. It's always positive. It's a scalar quantity. It just has a magnitude but no direction. That's it. Yeah, so let's think of that. Okay, the problem now tells us that this particular gap, okay, let me change the pen color. This one. Okay, so what it tells us is that it has to be, the rock has to be 6.38 meters away from the head of the unsullied soldier for that to reach 15 meters per second by the end of its descent, right? So quite reasonable. 6.38 is actually a reasonable answer. So let's say you're taking an entrance exam and you end up with that kind of answer for this kind of question. It's not quite questionable. So once again, the last step in problem solving is to make sure is to evaluate your final answer, meaning to say, look at the value, whether it's reasonable or not. And from there, you can decide whether you have to review your solution or not. So in this case, I would question this number. Actually, I think the typical height of castle wall would be around 12 meters, so this isn't really bad. Like maybe when the unsolved are like halfway through the height of the wall, they can start throwing those rocks and it will reach their desired velocity, which is 15 meters per second. But anyway, going back to the main question, 10 meters per second indeed is actually fast already. And even if you don't make that rock get thrown downward, even if you don't make it case two, it's still gonna hit the head of the unsullied with a strong force, with a really massive force um because of the kinetic energy associated with it, right? Those rocks are actually massive, and kinetic energy is proportional both to mass and velocity. So the mass can actually impact so much on the overall kinetic energy, and it will cause damage on the unsullied, like their face, or if their helmet gets hit, they will be out of they will fall out of balance as they climb up the ladder. So yeah, it's actually a pretty good strategy to be on top of that castle wall and then throw those rocks on the enemies. Nice one, Game of Thrones. Okay, so that's all for this problem. I hope that you understood it.